Right now, something unusual is happening on our sun that has caught the attention of scientists around the world. A massive dark region known as a coronal hole has opened up, and it is directly facing Earth. At first glance, it might sound like the sun is literally breaking apart or developing a dangerous void, but in reality, this phenomenon is a natural part of solar activity. A coronal hole is an area on the sun where the magnetic field temporarily weakens and opens up, allowing solar wind, streams of charged particles, to escape at extremely high speeds into space. What makes this moment important is the direction. Because this giant coronal hole is facing Earth, those fast-moving solar winds are now heading straight toward our planet. A large coronal hole on the sun is currently facing Earth, allowing high-speed solar wind to flow toward our planet. A coronal hole on the sun is an area where the magnetic field becomes weaker and opens outward, allowing streams of charged particles known as solar wind to escape freely into space. When such a large coronal hole is facing Earth, it means that a continuous flow of these high-speed particles is directed toward our planet. This is not a physical hole in the sun, but rather a region that appears darker in solar images because it is cooler and less dense than the surrounding areas. As the solar wind travels through space at incredible speeds, it takes only a few days to reach Earth. Once it arrives, it interacts with Earth's magnetic field, which acts like a protective shield around the planet. A coronal hole is a natural area where the sun's magnetic field opens, letting charged particles escape into space. When a coronal hole on the sun is directed toward Earth, it becomes an important event in space weather monitoring because it can influence several systems that modern life depends on. The fast-moving solar wind released from this region carries electrically charged particles that travel through the solar system and reach Earth within a few days. As these particles arrive, they interact with Earth's magnetosphere, the protective magnetic shield that surrounds our planet. This interaction does not destroy the magnetosphere, but it can compress and disturb it, leading to changes in its normal behavior. These disturbances are called geomagnetic storms, and their intensity depends on the strength and speed of the solar wind. During such events, satellites orbiting Earth may experience increased drag or temporary communication glitches. When solar wind reaches Earth, it interacts with the magnetic field and can trigger geomagnetic storms. The third key idea in this event is the role of geomagnetic storms and how Earth responds to solar activity coming from a coronal hole. When the stream of solar wind reaches our planet, it does not simply pass by unnoticed. Instead, it collides with Earth's magnetic field, causing it to shake and ripple like waves in a pond. This disturbance is what scientists call a geomagnetic storm, and it can vary from weak to strong depending on the intensity of the solar wind. During these storms, charged particles from the sun are guided along Earth's magnetic field lines toward the polar regions. This is where they interact with oxygen and nitrogen in the upper atmosphere, releasing energy in the form of light. That process creates the glowing auroras often seen near the North and South poles. While this natural light show is beautiful, the storm itself can cause practical challenges. These storms usually do not harm humans directly, but they can disrupt satellites, GPS systems, radio signals, and power grids. The fourth important aspect of this phenomenon is the way modern technology is affected by solar activity coming from coronal holes. In today's world, so many systems depend on satellites orbiting Earth, and these satellites are directly exposed to space weather. When a stream of fast solar wind reaches Earth, it can increase the density of charged particles in the upper atmosphere. This creates extra drag on low-orbit satellites, slightly changing their paths and making it necessary for scientists to adjust their orbits. Communication systems that rely on satellite signals, such as television broadcasting, Internet services and GPS navigation can experience brief disruptions or reduced accuracy. Airlines sometimes also adjust flight routes over polar regions to avoid potential communication issues during strong solar events. On the ground, power grids are designed with protection systems, but in rare and extreme cases,